Today we are going to explore one of the deepest mysteries of the ocean, hydrothermal vents.
Hydrothermal vents are formed at great ocean depths, around 3 miles beneath the surface. They are trenches created by weak tectonic plates that are spreading apart and are most commonly found in the Pacific Ocean's Ring of Fire. The Ring of Fire is also surrounded by earthquake zones and volcanoes. Here, magma sinks deeper into the ocean, creating the hydrothermal vent communities.
Temperatures in the vents can reach over 700 degrees Fahrenheit, which is the highest temperatures that organisms are recorded to survive in so far. But the surrounding water never boils because the vents are so deep within the ocean, which makes the pressure extremely high. The intense heat causes hot mineral-rich water to spurt out, and it then mixes with colder water as it heads toward the direction of the ocean's surface. In the colder water, minerals are less soluble, so they precipitate into the ocean as solids. This causes black smoke, which is full of hydrogen sulfide, to radiate out of the vents. Minerals with lighter colors produce whiter smoke.
Hydrothermal vents are known for their obscure and fantasy-like organisms. For example, the deep-sea angler. This fish is most commonly known for its lamp-like dorsal spine that hangs in front of their mouths like a fishing pole. This contains a light-producing organ called a photophore. Because it's so dark in this ecosystem, bioluminescence that is created by photophores are a useful adaptation for many deep-sea organisms. Deep-sea anglers are carnivores, able to eat prey up to twice its size and typically feed on crustaceans.
The yeti crab can tolerate low oxygen depths, so it survives near the vents. They must stay at a distance that is neither too warm nor too cold to avoid freezing or burning. So these baby crabs will never actually go into the vents. They wave their hairy claws near the black smokers to attract bacteria, their main source of food, and they occasionally will eat cracked open mussels. Because the yeti crabs do not have eyes, the claws detect if what they caught from the smoke is edible or inedible before consumption.
All of these organisms and life itself in the hydrothermal vents are able to survive because they use the unique process of chemosynthesis as a base of energy. Because there is no sunlight at the bottom of the ocean, it is impossible for producers to use photosynthesis. The ecosystem uses the different chemicals from the hydrothermal vents to convert into energy. For example, the hydrogen sulfide that is released from black smokers is a key producer of energy. The bacteria is produced from hydrogen sulfide and hemoglobin from host organisms, in which it has a symbiotic relationship with. In order to perform chemosynthesis, hydrogen sulfide is added to carbon dioxide and oxygen and then produces sugar, sulfur, and water.
Chemosynthesis is such an important process because it provides the organisms in and near the hydrothermal vents energy necessary for survival. It is the only way that life can exist in such great depths. Without sunlight, it is hard to imagine what life would be like, but the fact that bacteria and animals can exist in extreme areas using chemosynthesis, we question if other areas, like barren space, are also home to organisms yet to be discovered.